Alrighty, so let's go back up to PowerPoint 5.2. All right, the last thing that you and I did together was we could do the shifting left, right. What kind of functions are we talking about for these? Exponential functions. We can shift them which way? Left, right, up, down, and we can do a compress or a stretch. Okay, we can do a compress or a stretch, so I want to make sure we're okay with that. You have to be able to do that for the homework. And make sure there's one in particular in the homework that I want to make sure I go over with you all because that one's tricky. So I want to make sure I go over one. I think it's number 12 in the homework, but just remind me at the end. 5.2, number 12. So I need to go over that one. All right, so with that said, we're okay. Wait. Either 5.1 or 5, it should be 5.1, number 12. It's the one that asks you to graph it, and the box pops up to the right, and you got to put some stuff in the box. So that's number 12, I think. So just remind me to go back to that when we get done. Alrighty, so with that said, let's go to 5.2. Alrighty, so all the way up until now, we've talked about all these different functions. Here is a different type. It is just the inverse of the exponential functions. Logarithms are the inverse of exponential functions. So we're getting ready to talk about the inverse of exponential functions. So here is the first PowerPoint. And if you read it, you can say, okay, I read it, but it still don't make sense to me. Let me write it in the board in a way that should make sense. It should make more sense. So let me start off by writing this up on the board. I'm going to put y equals, I'm going to put y equals 3 to the x power. Here we go. Y equals 3 to the x power. Is that an exponential function? Yeah. How do you know? Because the variable is the exponent, the x is the exponent. So what if I say I want you to tell me what the inverse of that function is? Here are the steps to find the inverse. And that's what they're asking you to do here is turn that into the, I want to change it so that I have the inverse function. Step 1, switch x and y. Step 2, do something I created called the circle method. So here is step 2. So that's going to be, I'm rewriting the problem here so I can actually do the circle method. Here is what I call my circle method. You always start on the side of the equal sign where the exponent is. Always start drawing on the side where the exponent is. That's where you start. Alrighty? Not at the exponent, but the base number of the exponent. So this 3 is called the base. This is called the exponent. So you're going to start, put a dot underneath the base, draw it in the opposite direction from that side. So here I got my circle. Now I want to rewrite it in log form. We have it in exponential form. I'm now going to rewrite it in log form using my circle. So here's this step. This should say do circle method. Step 2 should say do circle method. Okay. This third step says rewrite in log form using the circle. Using the circle. Let me move so you can see what I just wrote. Rewrite in log form using the circle above. Alrighty, so let me show you what I want when I say log form. Now, the dot, and as you draw your circle, each thing tells you what goes in each box. So you always start with the dot. Where's the dot? Under the 3. So what goes in the first box?
3.
Second box. Whatever the arrow, the first arrow points to, what goes in the last box?
Y.
Done. So now I'm gonna rewrite it with the Y on the left side because I like to see Y on the left. That's just my own personal preference. I like it when Y is on the left. So I'm just gonna rewrite it, guys. This is not required, but I'm just gonna rewrite it because I like to see it like that. I like to see Y on the left. So it's usually, and even on homework, it'll have Y equals, and you gotta fill in the rest of it. So can you see that I didn't really change anything? I just like to have the Y over here on this side. You have now written the inverse of the original exponential equation. You okay? When it comes to doing this yourself, I would like to see the circle on your paper. So if you're doing it for testing purposes, I'm curious to see how you know what to put where. Draw your circle so you can see what to put where when you're doing it, especially if it's on a test. I want to see if you remembered what to do. All right, so let's give you one to do. Y equals 4x to the, y equals 4 to the x power. I'm going to follow the same steps. What was step 1?
Rewrite.
Switch x and y. What's step 2?
Draw the circle.
Draw your circle. Starting from where?
The base.
Which is?
The 4.
Okay, so put a dot underneath the 4. Draw your arrow to the x and then back around to the y. Last step, rewrite it in log form, right?
Yes.
So I need my little boxes. What goes in the first box?
4.
Second box.
X.
Last box.
Y.
Y. Okay, now I'm just going to rewrite it because I like x. I like y being on the left side.
But is that required for the test to rewrite it? Would you like to know?
It's multiple choice. So again, you're just picking the right answer.
Okay.
For multiple choice purposes, they're going to write it like this. So the answer will end up like this. In the homework, the answer is going to be written like this.
Okay.
But if on your scratch paper you had it written up there like this part, it's still right. So I'm still going to mark it right. Okay? This is what that slide says. Does it make better sense the way I wrote it? You just turned an exponential equation into a log equation. All right, so let me give you some other ones because here is something else that you'll see in the homework. It's going to say 3 to the 2 power equals 9. And it's going to say, can you rewrite this in log form? Is it an exponential form? Yes, because it has an exponent that's in exponential form. I want to rewrite it in log form. So, does it have x's and y's in it?
No.
Then you can't do number 1. You can't switch nothing. There ain't no x's and y's to switch. You can only do step 1 if it has x and y in it. Got it? Only if it has x and y do you do step 1. Otherwise, we skip all the way to what?
The circle.
Okay, so skip step 1 and go to step 2. Alrighty. What does step 2 say? Do? Alrighty, well, let's do our circle. Alrighty, where should I put my dot?
No, at the 3.
Okay, always put your dot on the side wherever the exponent is. Wherever the exponent is, look for where the exponent is, and that's where you got to start. So, and we did this on purpose so you can see that it's going to come out perfect regardless of. So now my circle is going to go this way. Somebody tell me what goes in the first box.
3.
Second box.
9.
Last box.
2.
Done. So, does it matter whether you draw the circle this way or whether you draw the circle that way? No. That just tells me how to fill in my box. Wherever I put my dot is going to be my first box, and wherever my first arrow is going to be the second box, and then my last arrow is going to be the third box. Don't matter which way you draw it, this way or that way. Sometimes you have to draw it curved going this way. Sometimes you're gonna have to draw the curve going that way. You gotta look at where your exponent is to determine where you put your dot.
So the key is the exponent.
The key is look for the side of the equal sign where the exponent is. That's how you know where to put your dot. Alrighty, here is something else that you may see. What if it has something like W equals 4 to the S power, and I say rewrite that as a log. Does it have X and Y in it?
No.
Then you can't do step 1. You only do step 1 if it's got X and Y. So do I jump straight to step 2?
Yes.
Yep, straight to step 2. So here's step 2. Where should I put my dot?
At the 4.
Okay.
Oh, I keep getting that confused.
Why?
I don't know. The exponent is the 4, right?
The exponent is the S. Remember, the number that sits up top is the exponent. The 4 is your base for the exponent.
So the 4 is the base and the exponent is the 5.
And that's a S.
That's an S? Okay.
It's a S. Okay, so now I'm gonna write my log. I need a box here, and the box there. All right, what goes in the first box?
4.
Second box.
W.
Last box?
S.
Done. Okay, I just wanted you to see it multiple ways so you could see if you saw this in the homework and it said rewrite it in log form, you would know what to do. You only switch with X and Y's. Don't ever switch if it ain't got no X and Y's in it, you can't switch it. And I mean both of them, it's got to have an X and a Y for you to switch it. Otherwise, you go straight to the circle method. Okay, questions? Well, let's take a look and see what these look like when you graph them. So we're going to graph the first original function and the exponent that we got. So let's go to Desmos and graph. When we get there, here's what you're going to see. For log functions, they always have an x-intercept. It always touches or crosses the x-axis. When we did the other ones with the exponential, it didn't touch, remember? So for these, it's going to touch the x but never touch the y. Notice it says the y-intercept is none. It never, ever, ever, ever touches the y, which is called an asymptote, but you don't need to know that word yet. But it never, ever touches the y-axis at all. The domain is all the real numbers that are positive, and the range is every number in the world. So let's graph it so you can see what both of them are going to look like. So if you go to Desmos and put y equals 3 to the x power. So let's go there. Desmos is here. Let's delete that one. Y equals 3 raised to the x power. There's your graph. We okay? Alrighty. What if I put in the inverse of that? Here's the inverse. Y equals log. I just literally type log. You don't have to. You could. It's on here under. Let me see where the word log is. If you want to see it, where is it? If you want to see the word log, it's under. Let me click over here again. If you open your keyboard up, click under functions and miscellaneous, and right here is the word log. If you also click this one, do you notice this one lets you put a little bitty number? Remember, we got to write it with this little bitty 3 down bottom. If you click the log with a little bitty a at the bottom of that G, it lets you put a little bitty number there.
But if you don't click that, how do you put it in?
Oh, if you don't click that, you can put it in this way. Let me close that window. Click on ABC and see how this little bitty thing right there. Well, I was on the wrong one. Hold on. Delete that. Let's come back down to this one. This is the one I want to put it on. Click ABC and then click this little button right here. It lets you put a little subscript number there, so I can put a 3. Now, once you put it, if you don't go back up, what happens if you don't go back up? It's going to continue putting things on the bottom. So now you got to take your cursor and cursor back up so it's at the same level as the log, and now put our x in. And let's move my keyboard so you can see. So you have the original exponential function and you have its inverse on the same graph. Now notice, This one is the exponential function. It does cross the y-axis, but it never touches the x. For the log function, which is in purple, it crosses the x-axis, but never touches the y. Now, I know y'all looking at this picture and you be like, it look like it's touching it to me. It is not touching it. So, I know it looks like it's touching it, but if we actually took the screen and made from here to here wider, you would see that it's not touching it. But because we got this from 0 to 5, it looks like it's actually touching that. It's not. It's never supposed to touch it. So, for the exponential function, it never touches the x-axis. For the log functions, it never touches the y-axis. Yes?
Do we need to know that for test purposes?
For the reason I'm saying it is because what if I graph it and it's the wrong graph? So, for example, if I say, is that an exponential graph or is that a log graph? You know it's log now, but would you know it? If you see what I'm saying? Which one is that one? So, you know the one that's the log graph can't touch the y-axis. So, and it gives you an idea of what they look like. So, the goal was to kind of give you an idea of what they look like. This one,
They ask us on the test which is log, or which one is touching.
in the homework, it's going to say graph it. It's going to say graph this function, and then it might say graph the inverse. And so that's why I want you to see what both of them look like. So you always know that when we do y equals 3 raised to the, whoops, that's not raised to the x power, that you always know it's going to look like this.
And that would be considered the inverse.
This is the original one. I just retyped this one back in. This one right here, the one going uphill, that's your original function. The purple one is the inverse.
So we're still only paying attention to that line quadrant.
Say it again.
So we're still
Yeah, we're looking at, you're still looking at what's in the quadrant one.
quadrant one.
Okay, questions? We okay? All right, so if I go back to the PowerPoint so we can figure out where we are, you just looked at the graph because that's all it was supposed to do was show you what the graph looks like. So now you know exactly what your graph will look like. On the next slide, it wants you to make sure you understand the difference between a common log and what a natural log looks like. So we're gonna do common log first and then do natural log. Common log is what's on your calculator. You see the word log on your calculator? You see we typed log up here on the screen? Common log has no little bitty number that you see here. You see what I put a 3 and I put a 4? Common log is just y equals log of x. So I'm going to write common log up here. So this is what a common log equation looks like. Y equals log of x. Now, I didn't say how to read this. Let me tell y'all how to read this. This is y equals log base 3. This number, you read this as base 3 of x. How do we read this one? Y equals log base 4 of x. This one, you just say log, y equals log of x. Now, there's an invisible number here. There's an invisible number here because it's a 10y, because we count in base 10s. We count 0 to 9 or 1 to 10. We count in base 10. So there will never be a point where you put a 10 here. You can put all the other numbers of 3 or 4, 15, 25, whatever number. You will never put 10. It's assumed that if there's no number, you know it should be a 10. Your calculator automatically thinks that if you hit the LOG button on your calculator, you should look at your calculator and see if you got the LOG button on there. Do you see it? Your handheld calculator should have the LOG button on there. Okay? It should have this button with no number. Some of you got a calculator that has that button with a number where you can change it. So you definitely have to have this one. You got this button. On your calculator, it should have an LOG button on it. That's called the common law base 10. You will never see the 10 at all.
Unless you type it in here.
You never should type it in. Whenever you're using base 10 for this, you never type anything in the little space like we got a 3 here and a 4 here for log base 3 and log base 4, you never put a number for 10. You just put log of whatever the number is. So if I say what's y equal log of 5, you should just hit, so if I said this, if I said y equals log of 5, you would go, you would hit log, then 5.
It's still assumed that 10 is there.
Correct. Your calculator, because you're hitting this button. You're not hitting the button that lets you change this number. You're just typing in this just like it is, and the calculator knows that that's base 10.
So you still have to do that little exponent to hit the 5 though, right?
No, that's not an exponent. No. Notice the difference. I didn't make it up high. It's at the same level as LOG.
Because it has that comma right here, log, comma, and then you would put the 5?
I need to see your calculator, because some calculators you type it in a certain way. So I would need to see yours just to see how it has it set up. Because it should have does yours just say LOG on the button and then a comma and then something else?
Well, when you hit the log, then the comma is the log.
It may be asking you what to put in for
And then
that.
I guess you put the
Right.
letter in.
But I need to see it for sure just to make sure. So let me see. No, you hold on. Let me make sure we got to where we get to, and then I'll look at yours specifically. All right. So base 10, there's no little subscript number at all. This is called the common log when there's no little subscript number at all. We okay? The next slide is called natural log. So here's the natural log. We just did common log. The next slide is called a natural logarithm. I'm just going to write natural log up here. And the symbol that we use for natural log is LN. Do you see that on your calculator? Look at your calculator. Do you see LN? It looks like IN, but it's LN. Now, of course, I know you're like, well, why they call it LN if it's natural log? We ain't created, so it should say ln of x. You're taking the natural log of a particular number. So you're going to see it written like that. Well, you're like, well, where did that come from? Well, let me show you how we came up with that. Let's see if I'm going to have space to do it right here. Let me finish this part right here. If you have e to the x, oh, nope, I want to write it with a y. I just want you to see how we came up with this, how we got to here. Is this an exponential form? Yes. Is the e a number or a variable? A number, okay, so you were good. So it's in exponential form. So I'm gonna follow the steps that we did up here to show you how we get to y equals ln of x. Alrighty, so when it's got an x and a y in it, what we supposed to do?
Switch it.
Okay, so we're gonna do step 1 and switch. Oops, that's not right. Okay, step 2, do the circle method, right? Ready, so now. All right, here is my circle. Now I'm going to rewrite it in log form. Now, here's the key. If it has an E in it, you can't use LOG, you got to use LN. Got it? You can only use LN, which is natural log, when it has E as the base. Notice when we did the ones up here, we didn't have E in it at all. If it has the letter E in it, which is a constant, which is a number, you have to when you write it back as log form, you got to write it with LN. So let me write what I'm expecting you. So you just did the 2. Here's the 3. We're going to rewrite it using natural log, using LN. So this is going to be, I'm moving a second so we can see, so you can see. Alrighty, so what's going to go in the first box? E. Okay, Second box,
X.
last box.
Right.
Okay, now I'm gonna rewrite it for you. You see what I did? I'm gonna rewrite it. You will never leave the E where it is. It disappears like base 10. So I'm gonna rewrite it. Y equals ln of x. Do not put that E in there. It's invisible. When you write it, it will not have the E in there. Yes.
What is the E again?
The E is just a constant. It means the 2.71828. It's like pi. It's a number that they created that references the letter E. They use E for that. So E is never a variable in this case. It's always a number. So when there's an E in it and they say write it in log form, you always use LN. Always, always, always. You cannot use LOG at this point. Yes.
What is log?
What is what?
Like what is log? Like when the
When you say what is it doing, it's like when you want to turn an original equation into its inverse, you have to use that function. Meaning, I'm saying that's what it is. It's just a type of function, but in order to rewrite the exponential form, you have to write it in log form. So we just took this original equation that's in exponential form and wrote the inverse, which is now in log form. So you need logs to write it as an inverse. Now your question might be, well, where do you use it? When does it make sense? Where does it make sense to use it? Is that part of your question? Like when? So that should be, let me see if that was on a previous slide. Did I use that on a previous slide? I don't think I did. Alrighty, so let me get to where you were like, when will we ever need to use this? On that slide. That's a slide forward. You're like, when and how would you ever need to use this? You won't use it unless you want to be, what's the earthquake chaser? Is a seismologist. So when they're determining what the intensity of an earthquake is, they're using logs. So it's just a formula. So you think of it's just a formula that's being used to determine a particular type of equation. But this is, for what we're doing here, we're starting with an exponential equation and turning it into log form. The only way you can turn this into the inverse is you've got to use logs, and it's just a type of formula that you have to use to do it.
Can you do that by hand or do you have to use a calculator?
Could you actually calculate it by hand? It's kind of like, when you put data in Zuru and be like, it creates an equation, it would take you forever and a day to create that by yourself. So that's why we have tools that you can use. So log just happens to be a type of equation that you can use to convert from exponential to log form, to its inverse. But in terms of real life, when would you ever use it? If you're going to be a seismologist, the software that you have uses this. But I'm not going to be an earthquake chaser, so no. This will be the only time I'll use this is in here with you guys. So that's that's the real life situation for that. But let me go back up to where we were, right here. So again, if you see an E, you got to turn it into this if they ask you for the inverse. We okay? All right, well, let's see what the graph looks like. Just so you know what the graph looks like when it's a natural log as opposed to common log. All right, back to Desmos again. So here's common log again, equals log of x. We got our curve. There's my curve. And what if I use y equals natural log of x? They're similar. Now remember, this one is the inverse of that one. Excuse me, this equation is the inverse of that one. And the one that's in the red, and this is the inverse of that one. So here's the original equation, here's the inverse. Here's this original equation, here's the inverse. I just wanted you to see that they still look like natural logs. They still look like, hold on, let me put this back up here so you can see. Remember what I had on the screen with delete, y equals 3 raised to the x power. And then I put in here log y equals log, put my little bitty 3 here. back up, and all right, so I just wanted you to see what both of the curves are gonna look like. So the exponential curve is gonna look like what you see in green. The inverse curve is gonna look like what you see in yellow. We got it? So now I'm doing the same thing with the other one. So if I got E here, and let's take this out and put natural log. So I just wanted you to see, look at those two. Here's the original one, here's its inverse. Yes.
What's the point of changing it? You wanna change it back anyway?
When you say change it, if you're going, what do you mean, change it back?
So, when we did the inverse, the first step was to change X and Y.
Yes.
If it had X and Y in general. And then when we ended up with the answer,
Yes. You're saying, did we switch X and Y back? We didn't switch X and Y back. I just rewrote the equation in a different order, but you're thinking I switched X and Y back again?
yeah, it was like you did.
So here's what you're saying. Now, did I switch X and Y, or did I just rewrite the equation and put Y over here? I didn't replace this with an X and that with a Y. You see what I'm saying? I just turned the equation around, but I didn't actually switch these two things. You see what I mean when I say I didn't switch them? It looks like I'm switched them because of the way I wrote it. But these two are the same thing. So for example, again, so just to make sure you understand what I just said, can I write this way? And can I write it this way? Did I switch the 3 and the 5? No. It's the same thing written two different ways.
But if you
But-
wrote it the other way, that would still be right.
Both ways are right. Yes, both of these are still right. Both the ways you see it is right. I just want to make sure you understand. I didn't switch the X and Y's when I got down here to the bottom.
Right.
Up here, I switched the X and Y's. But down bottom, I didn't switch the X and Y. I just rewrote the equation in a different order.
You just dropped the exponent sign, that's all.
For, you mean for this?
Y equals the natural log.
Right, for that one, now look back up at this one. For this one, I didn't drop that 3 because it has to stay there if it's any number but a 10. So here, again, it looks like, does it look like I switched X and Y here?
No, I mean, like, the X is still gonna be an exponent. It looks like it's gonna be the same thing, you just put 3
Does it
in
look-
smaller thing.
Okay, so, and this should look like the X is not the exponent, it actually should be at the same level as the LOG. So this shouldn't look like this is an exponent. I don't want you to see that as an exponent. Did you see it as an exponent? No? Okay, just trying to make sure. Question?
So, I don't know if I'm following her, but I'm wondering, if it's other letters, we don't have to switch it.
Correct.
And what makes X and Y different than the other letters if they're just letters?
Because you're working with a function that has variables that are, I wanna say the word standard. It's a good question. I'm trying to figure out what's the best way to say that. If you have an X and a Y, it's kind of like, you know, when we were doing linear equations and we had to switch the X and Y. So you have to do it here as well when you're solving for the inverse. But I don't think I'm doing a good job of explaining to you why I don't have to switch it with these other ones, even though I do. When it's numbers, of course, there's no need. But when, in this particular case, I have letters and numbers in this one, and you don't have to switch it. But there's something standard about X and Y that's required that you have to switch it. I'm trying to remember how to say it properly. And I'm not saying, let me come back and think about what you're asking me to make sure I can explain why you have to switch it with X and Y. So let me think about how to say that. Okay, hold that thought. Let me think about how to say that properly, why you gotta switch it with X and Y, but not with the other ones. Here's the thought that I just had. So for example, let me use this case. Let me use the 3 to the 2 power equals 9. Okay? Now I know that this is not X and Y, but that's what they would be if they were up there. Let me write it like you see it up there. Okay, so over here, you've got Y equals 3 to the X power. We just switched them. If I switch this here, will it make sense is the question. So if I take it and switch them, so here if I say I'm gonna switch where we switched X and Y, we're gonna switch 2 and 9. You understand what I just said I'm getting ready to do? Okay, so here, we switched them. Okay? Over here, I'm gonna do the same thing. So I'm gonna switch the 2 and the 9. I'm gonna put a 2 here, and I'm gonna put this here.
That's two different answers.
I agree with you. Is 2 equal 3 to the 9th power?
No.
No, so you can't switch it.
Got you.
You see what I'm saying? You can't switch it. If it's X and Y, you can, but if there are numbers or other things being used, you can't switch it because it won't mathematically be equal. So you cannot switch them when there's other things other than X, Y.
I have a question. Now, y equals 3 to the x, right? And x equals 3 to the y. So you're saying that y,
At this point, we're just saying, you don't know what these numbers are at this point.
okay, that's what, because that's equal then.
Right, but you don't know what
With the
these,
x and the y.
right,
But if we put numbers in them.
you can't
then they-
switch it,
yeah,
right.
okay.
There would be no need for you to switch it, that's what I'm saying.
Because
There would be no need for you to switch it if you got it set up like this without X and Y in it.
But that's, okay, so like if we have y equals, and we switch it, and then we, oh God, I'm trying to ask you. So then, say for instance, if we put y equals 3, oh no, okay, I got you. If you have numbers there, you just can't switch it, even if you have one number in the exponent, you
Can't
can't
switch
switch
it, right, you're only switching it when there's just an X
it.
and a Y.
Okay.
Now, the other thing that I want you to understand, this is just a process for how to get to the log function or the log form. It's just a step-through process. You understand what I mean when I say it's a step-through process? The circle method, and with this switching them, I created that myself. It's just a process for you to figure out how to get down to this equation. You see what I'm saying? I'm creating something easy for you to remember how to do this. Usually when this is taught, they'll just say, hey, okay, 3 to the x, okay, logarithm is y equals log base 3, and they'll tell you how to get there. There are no steps for how to get there, and how they explain it in that slide that I give you still doesn't make sense. So I created just something simple for us to get from step 1 to step 3. You see what I'm saying? And I used a pattern that only you have to switch it when there's an X and a Y, and when there's not an X and Y, you don't have to switch it. So again, that's my own creation kind of thing, so
When it's not an x and a y, you go immediately to the circle.
immediately to the circle method, absolutely. All righty, so you can ask me another question as I keep thinking, you know, if there's an easier way for me to say that. Let's go on to the next slide, and then we can come back if you still have other questions. What were you saying?
The signing sheet.
Oh, it's right here. It is right here. Thank you for reminding me, because I wasn't even noticing people are leaving and they ain't signed in yet. I'm putting both on the same page, so you guys can sign in for both. Today is the 17th. There you go. All right, so let me see, what's the next slide say? All right, so we just did so you can see what it looks like on the screen. Now, here's the part where I want to make sure you guys are okay, because these are properties that are just like, when you know a rule of mathematics, it's just a rule of mathematics. Do you understand? That you have to follow it, whether you be like, like for example, I think we talked about 3 to the 0. Like I said, anything raised to the 0 power is what? 1. But you be like, why that ain't 0? It's a rule of mathematics, and it is what it is. So it's like we just gotta kind of accept these are properties. Let me explain, and let me show you what I mean by them when I say explain. So I'm gonna give you examples of each one so you can see what it means. So first one. Here's the first property. It says log base b of b equals 1. There is no exponent here. These are just log properties that they want you to be familiar with. So let me put in real numbers for everything so you know. So here's the property, here's the example. Log base 4 of 4 equals 1. So what they just said in that property, when the base and this base are the same, what's the answer always gonna be? 1. It don't matter if there's a 4 and a 4, a 5 and a 5, a 6 and a 6, 7 and a 7. If those two numbers are the same, the answer is 1.
Okay, so that's when b is greater than 0, but b is not equal to 1. That's what it said.
They just want it to be positive and not 1. It gotta be positive. but we don't want it to be one. That's all they're saying, don't do this. They're saying don't make a 1 here and a 1 here, don't make all of them ones.
Okay.
That's what it's saying, don't make it be a 1, so it'll be anything bigger than 1. So it'll be a 2 and a 2, 3 and a 3, 4 and a 4, 5 and 5, and so forth and so on. So I'm gonna go back and put it as, we
So
had
it
a,
has to be more than one, but it can't be more.
correct. So that's property number 1, the first property. So I just gave you an example of that one. All right, here's the next one. Log base b of 1 equals 0. I'm gonna put an example here. Here's the example. Log base 3 of 1 equals 0. Here's what that property says. And this is a b, guys. I don't want you to think that's a 6, that's a b. All right, log base 3 of 1 equals 0. It doesn't matter what number you put here. It could be log base 4 of 1, log base 5 of 1, log base 6 of 1, log base 7 of 1, answer 0. Let me show you how to check these. If you're like, well, how would I ever know I got it right? Let me show you how to check these, and I'll do it with the first one as well. Let's say, well, I want to check and make sure I got this right. Here's to check it. Guess what I'm going to do to check it? The circle method. Put a dot here, to here, back to that. So this arrow always points to whatever's in this space, the whole entire thing in that space. All right, let's check it. I'm going to rewrite it. This is me checking it. Rewrite it in exponential form to check it. All right, what goes in the first box?
3, 3.
Second box. Last box. Is this a true statement? Yeah. Then you know you got the right answer. In the homework, it's just going to say, what's log base 3 of 1? And you're going to say 0. I'm just saying, if you want to know how to check it and see if it's right, you can check it using the circle method with logs. We did the circle method with exponents. Now you can do the circle method with the log. Let me check this first one so you can see how to check the first one that we had up here. Here's the first one. Alrighty, put a dot here. Draw your circle. 2 here. So, box. All right, what goes in the first box?
4.
Second box. Last box. Is that true? Is 4 to the 1 power equal 4?
Yes. Yeah.
Yes. Alrighty, here is the next one. It says log base b of b to the x equals x. And I'm trying to make sure I'm writing it at the same level so you don't think it's an exponent up here. Alrighty. Let me give you the example. Here's the example. Log base 3 of 3 to the 2 power equals 2.
This is rule number 3.
This is rule number 3. That is correct. What does this rule say? When these two numbers are the same, what's the answer? The other number, which is 2.
Oh, the exponent.
Right, it's the exponent.
Oh,
When you have log base 3 of 3 to the 2 power, the answer is the exponent. So I'm looking at it, if these two numbers are the same, the answer is whatever the other number is, which happens to be the exponent.
And what if they different?
Then that rule doesn't apply. This rule only applies when both of these are the same. That rule only applies, this property only works if both of those are the same.
And you can have an exponent of 4.
Any exponent you want, you can put a 4, 5, 15, 25, 36. Don't matter what the exponent is whatever this number is the answer. Alrighty, so, you okay? How do you check it? You want to check it?
Circle method?
Alrighty, box here, here, and here. This is just us checking it. Alright, what goes in the first box? second box?
2.
What goes in the third box? What goes in the third box?
3.
What goes in the third?
2.
I heard somebody say it.
I thought I said 2, but I don't know if that's 3. Oh,
3 squared.
What goes in that third box is whatever this whole entire thing is. All of that. Not just the 2. You see? When we did the circle method here, we did 3 to the 0 equals all of whatever this whole thing is in that space right there. So is 3 to the 2 equal to 3 to the 2? I mean, 3 to the 2 is 9, 3 to the 2 is 9, so they are equal to each other, right? So that's right. That's how you check that one. All
It's
right.
gotta equal though.
Say it
It's
again.
gotta equal.
They should, yes.
If they
If-
don't
when you're
equal,
doing your
you're
check.
wrong.
If you set it up and they don't equal, then you made a mistake somewhere. All right, here is the next one. It is B. Raised to the log base B of x. Question, what is the exponent in this? The whole entire and log base B of x, all of that whole thing is the exponent. So you can't say just the x is the exponent. No, the whole thing is the exponent. Well, what's the answer?
What you mean, what's the answer?
I'm saying right here with this one, what's the answer? The answer is x. Well, let me put it in some numbers. Let's put some numbers in it. 3 raised to the log base 4. Excuse me, I wrote that wrong. Let me see if I got it at the right level. What's the answer? Yeah, I don't know why I got the equal sign way up there. The answer's what again? Now, this one's written in exponential form. What were these written in? Log form, log form, log form. How do I know this was written in exponential form? Look, exponent form looks like this. So even though it has log in it, the log is the exponent. So it's already written in exponent form. These other ones had the word log written in the front. So again, just trying to let you know, this one's already written in exponent form. So when you check it, you're not going to check it in exponent form. You're going to check it back in log form if you want to check it.
Okay,
I'm listening.
why is it equal to 5? You just bring down the exponent.
Okay, so I'm going to say this part. Again, some of this, I don't want you to try to make a whole bunch of like, I want you to see that if this is a 3 and that's a 3, and those two numbers are the same, what's the answer? The answer is the other number.
Gonna be the exponent.
That's not the exponent. The whole thing is the exponent. This whole entire thing is the exponent.
Okay.
So it's part of the exponent
Okay.
is the answer. That part is 5 is the answer.
So if it was 4, then the answer would be 4.
So let's do another one. Let's put another one up here. So I've got 4 raised to the log of base 4 of 6. What's the answer?
6.
Alrighty, I've got 5 raised to the log of 15, 15 raised to the log 15 of 9. What's the answer?
9.
Okay.
But how
So,
would,
but that's like the 9, I mean, it's just, I'm a little confused because I don't see how that equals, I don't see how it equals to 9, I don't see how it equals to 6,
Well, yeah, I
and I don't
work
see how
that
it
out.
equals to 5.
you just assume.
Here's what you're saying. You don't see how it equals because in your head, you can see that 3 to the 2 power is 9. And you're like, oh, that makes sense to me. I don't even know what this is in my head. I don't know what log base 15. I have no idea what this is.
So
It
it's
could be
on the
3.
format.
Right. You're just looking at the format. Because I don't know what this is in my head. I got to put it in my calculator. So when you put it in your calculator, it should come up to that. So that's the point. If you put this in your calculator, the answer will be 9.
So don't worry about checking that.
I'm just showing you how to check it, but you don't have to.
Okay.
My key for this is for you to remember the property. That if these two numbers are the same, the answer is the other number.
So we do have to know these properties?
Will you see it on the homework? Absolutely. They're going to give you stuff just like this with no answers. Ain't no answer gonna be there. They're gonna be like, what's that answer? You gonna say what?
Unless we.
5, and you gonna say what? 6, and you gonna say what? 9. I'm just saying you're gonna see that as homework problem. Yes. Yes, it does. It does. So, I mean, that's what we just said. If you put this in the calculator, it's gonna equal 9. The key is how you put that in the calculator. So not only do you have to deal with exponents, but you got a log base 15 of 9 that's gotta go in the calculator right for you to get the answer 9. But I'm just saying, if you don't put it in the calculator, answer just 9.
So what, so after you get 9,
Yes.
okay, so it's saying like 15 log, and 15 log to the,
So this is 15
Yeah.
raised to the power of log base 15 of 9.
of 9.
Correct.
Is 9, so that's kind of like saying if you take 15 and put it in an exponent of 9, it's gonna,
If I take 15 and put it as put in the exponent of 9, it's gonna equal something different.
yeah, so that's not.
It's not gonna equal the same thing. So let me put one of these in the calculator so you can see what this looks like in the calculator. I'm trying to see if there's another one. All right, so let's go back to a web calculator. This is the one that I usually use. All right, so let's see what this looks like. All righty, so let me do the first one. 3 raised up to the power of, what am I putting in here? Log
3,
base 3. Hold on, let me go get my log button because it's the wrong one. Here's the log button. Nope, that's not the right one. Nope, that's not it either. Hold on. I'm just trying to see where it put the base at, where I could change the base of it. And I don't see it here. Hold on, let me pull up a calculator that has, okay, I don't want to do that. Let me see, log calculator, let me see what this one does. That's base 2. I want to use a different base other than 2. Nope, that one's not it. All right, let me go back and do it in Desmos, see if Desmos will put it in there for me. All right, delete, log, and I'm going to do base. Let's do it, let me rewrite it first. What am I putting up here? 3 raised to the power of log base 3. Come back up. 5. Do you see the answer?
oh, 5,
Do you see the answer right here, guys?
yeah, equals.
This is in Desmos. I'm just using Desmos like it's a calculator. So I typed in this first one right here. I typed in that first one. So you can see if you actually type it in Desmos, it gives you the same answer that we said it was gonna be.
So when if you do it in Desmos, do you have to put the first parentheses without closing it, or can we just do log to the exponent of log?
Well, let's see what happens if we don't put the parentheses in. So we'll see for sure, so we'll know whether we do or don't. We're gonna do the next one was 4, 4, and 6. 4 raised to the power of log base 4 of 6. So if you look at both of them, you see I didn't put the parentheses on the second one, but I did put the parentheses on the first one. I would prefer, if you're using your own handheld calculator, that you put this in parentheses. Because otherwise, you don't know that it's gonna read it right if you don't put the parentheses. So I would say, do what I did on the first one and put the parentheses around log base 3 of 5.
However, we just, we really don't need a calculator for that.
No, you don't. That was the whole point that was the whole point that I wanted to make with this. I don't want you guys to go too deep on it. If those two numbers are the same, the answer's the other number. Done. Same thing with this last one. If the B and the B, if that's a 5 and a 5, the answer is whatever the other number you see on a part of that problem. So yeah, I don't want you to get too deep with it. Just know that these are what you're going to see in the homework. Bullet number, the next bullet is going to be included in this one. So let me jump right into this one and then we'll stop. So this last part is very easy to do. Here's the last part. Let me push this up. Last part on the board says, if you have log base B, where you see those little bitty B's, guys, they could put a number. It could be base 3, base 5, base 15, base 54. They're just using the B as whatever number you want to put there. Right now they're using just the letter B for whatever number. And they're going to say if this is log of M times N. That's a times sign when you see two variables sitting beside each other. So let me rewrite this in English so you understand. If I have log of 3 times 2, what does that become based upon the property? Multiplication turns into addition. So that's going to be log base 3 plus log base 2. You good?
I got a question
About the what? The B. You should keep the B's there. Those little bitty B's should stay. They don't do anything, they just there.
It could be numbers too?
Yes. It could have been log base 8, log base 9, log base. These numbers could have been anything that the homework wants it to be. Just leave them right there. Don't touch them. Don't do anything to them. All you're going to do is see what these two numbers are and rewrite it as addition.
But we're not going to add anything.
Nope.
Okay.
Not yet. In the homework, eventually what it's going to do is it's going to say, given, I'm just showing you this because right now this is just the properties I'm explaining. Given log of 2 is equal to 1.5, and it's going to say log of 3 is equal to 1.7. Let me make it an easier number. Let's just make it 2.5. I'm just making these up, guys. Let's say this is 2.5. Alrighty? So, in the homework, it might say, well, what's the log of 3 times 2? And what are you going to do with the log of 3? Replace 3 with what? And replace log of 2 with what?
1.5.
Now add those together, and what is that? So it may ask you to do something like that. But the goal, what I was getting for you now, was just to show you what the property says. Okay, multiplication turns into addition. Thus, division turns into what? So you've got log of 5 divided by 3. I'm making up some different numbers, guys. Doesn't matter what numbers you use. 5 divided by 3 is going to be log base B of 5 minus log base B of 3. So division turns to subtraction. Exponents. What if I have log of m raised to the n? In this case, it might be log of base 5, base b. Those b's, that b here, this might be 5 raised to the 3 power. What happens when it becomes an exponent? The exponent gets pulled to the front. The exponent gets pulled to the front. So that's going to end up being 3 log base b of 5. So, do you see what I'm saying? If there's an exponent, the exponent gets pulled to the front. If there's an exponent, you pull it to the front in front of the word log. So again, multiplication turns to addition. Division turns to, and exponents get pulled to the front. Now this works backwards and forwards. If I give you addition, what can you turn it back into? If I give you subtraction, what can you turn it back into? And if I give you a number that got pulled out front, you can put it back as an exponent. So it can go both ways.
For example, the
The next slide is what we already talked about, which was the Richter scale for the earthquake intensity. We discussed that with the law. That's the end of 5.2. Okay, we will finish 5.3 and probably go into 5.4 on Thursday for sure. And test is still on what day? A week from Thursday. The 20, what day is that again? So we'll make sure we're all on the same page. I don't want you to say, no, you said it was, no.
It's our last test.
You're for your test 4. So your next test should be on the 26th of April, which is 1 week from Thursday.
Are we getting a study guide?
Yes, you'll get a study guide. I'll probably send the study guide out this weekend. Yes. Yes, oh, let me see, test, I should have. This is the Tuesday, Thursday class, there. Yeah, if you didn't get your test back, I have your test. Okay, so I have Samaj, Monet, Tania, Magali. Very well done. Monet. Very well done. Magali. Cool. Who else? Dexter's not here. Janelle. I got to go up to my office because they would have left it under my door and I forgot to get it. Anybody else didn't get their test back? Now remember, so we've got test 4, so you still get to drop a test grade. So don't freak out right now. We still got plenty of stuff to cover. Remember, you get credit for everything that you do on your scratch paper, so don't get worried right now. I know this is the time the students start freaking out now because you kind of see the end and you're like, oh my God, no. You're okay. You're okay. As long as you know you're doing your part, you're going to be fine. If you're not doing your part, then you know what the deal is. But if you're doing your part, you're good. You're good. Okay, let me stop the recording so it won't be like 5 hours long and then I can't